What we're looking at here is solving a three-variable system. So this is the same as if it was a two-variable system, like if we had x plus y equals 2, and another equation, let's just say negative 2x minus y equals 3, just making up some numbers. That's a two-variable system. We would solve for x and y, indicating the ordered pairs where these two lines would intersect at a single point in a two-variable system. Well, in this problem, we are looking at three variables, meaning three-dimensional space. So where 3 points intersect, so in x, y, z. So where 3 lines intersect one another at a single point. And hopefully, we'll see. But in a three-variable system, there's not like a rule book or an instruction guide of like, here is your starting point always. You just want to look for some easy starts. So the first thing I do is I number my equations. Just give me a little starting point here. And then I look for an easy elimination. And what I mean by easy elimination is I look for some sort of just simple operation like addition or subtraction that will just eliminate a variable somewhere. So if I look at my x's, I have 1x, 2x. I can't just add or subtract those two equations together to eliminate x. I got 1x, 2x, negative 3x. Any sort of combination with x is going to require a little bit more work. So let's table that for now. Let's go to y. Let's see if there's anything easy here. 1y, negative 3, negative 2. Still nothing easy. Look at my z's. Negative 1, positive 1, and then a positive 2. So right here, negative 1 and positive 1. I have coefficients of negative 1 and positive 1. Those are opposites. So I can add and eliminate z from equations 1 and 2. So let's go ahead and do that. So I'm going to take equation 1. I'm going to take equation 2. So this is equation 1. Take equation 2. 2x minus 3y plus z equals 3. And then, like I was just talking about, I want to add these two equations together because that will eliminate the z's from both because they're opposite of one another. When we have opposite signs, we want to add. So I'm going to add my columns. 1x plus 2x is 3x. 1y plus a negative 3y. 1 plus a negative 3 is going to be negative 2y. Negative z plus z is 0. I've eliminated the z's. That was my whole goal. 2 plus 3 is 5. Now I have created a new equation. Equation 4, we'll call it. So now I have an equation of x and y. So this is where it gets a little bit cleaner because now we have a goal. We're like, okay, I've eliminated z from equations 1 and 2, and I've created an equation with two variables of x and y. So what I want to do now is create another equation with x and y by eliminating z from equation 3. So I have some freedom here how I want to go about doing this, but I know right now I want to eliminate z from equation 3. I just have to figure out how am I going to do that. And if I look at equation 2, 1, 2, not an easy just add or subtract elimination. Let's look at equations 3 and 1. Positive 2, negative 1. Still not an easy elimination to make. So what I need to do is I need to do some manipulation here. I need to multiply either equation 1 or equation 2 by 2 or negative 2, whatever your preference is, to make them either the same or opposites. So let's go with equation 1 because if I go with equation 1, then I'll have opposite signs, negative 2 and positive 2. I typically like to just work with opposites a little bit. They're a little bit easier because then you're adding, but it's completely your preference. So when I do this, I want to change everything and multiply everything by 2 in equation 1. So I'm going to take my modified equation 1 here. I'm going to multiply everything by 2. So it's going to be 2x plus 2y, because 2 times 1, 2 times 1, 2 times 1x, 2 times 1y. 2 times negative z is negative 2z equals, don't forget, 2 times 2 is 4. As I was talking, I almost just wrote down 2, not even thinking, but 2 times 2 is 4 there. That's our modified equation 1, and like we said, we are using equation 3 still, so negative 3x plus 2y plus 2z equals 1. Now we had a goal here of eliminating the z's. That was our goal. But what ends up happening is exactly that. I was trying to look ahead a little bit, and I saw these two y's, and I'm like, oh, these are going to eliminate 2, but they're actually not. So the z's are going to eliminate. Negative 2 plus 2 is 0. 2x plus negative 3x is negative 1x. 2y plus 2y is 4y. Just as I was writing it down, I'm like, I think we're going to get rid of y's and the z's at the same time, but then I noticed they're same sign. So those are not going to eliminate because they're the same signs. 2 plus 2 is 4. Where here is going to eliminate. Negative 2 plus 2 is 0. 4 plus 1 is 5. Now I've generated a new equation again. So look what happens. I have an equation with x and y, equation 4 I've created. I have an equation with x and y, equation 5. Now we could just work off of a two-variable system, and we could solve this system using any sort of method that we want. So I'm going to create a new system of equations using equations 4 and 5. So let's go over here. So equation 4 was 3x minus 2y equals 5. That was equation 4. That was generated from, did I not write this down? Equation 2 was this one. And then take equation 5, negative x plus 4y equals 5. And that was equation 5. Now we do have to eliminate either the x or the y. And it's completely your preference. We don't have an easy elimination to make if we're going the elimination route because I have 3, negative 1, negative 2, and positive 4. So not an easy elimination, but still a pretty manageable elimination here if we multiply by 2 to make the y's the same. I think that's probably a good route. We could also multiply by 3 to make the x's opposites, or not the same, but opposites. So I'm going to go the route of multiplying the equation 4 by 2. 2 times 3 is 6x. 2 times negative 2 is negative 4y. 2 times 5 is 10. So that was our modified equation 4. And we're still working off of equation 5. We didn't touch that one at all. Now that I've made these opposites, negative 4 and positive 4, I'm going to go ahead and add my columns together because they're opposite signs. Negative 4 and positive 4, that's going to zero out by adding. 6 plus negative 1 is 5x. Negative 4 plus 4 is 0. 10 plus 5 is 15. One variable equation. Solve for x by dividing by 5. X equals 3. Look at that. We now have an x value. So now we go back and substitute it back into any of our options, really. I don't know if I'm like not catching or something. But let's plug this back in to really any of them. I'm going to go with my original 4 here. So I'm going to plug in x equal to 3 into equation 4, which is going to be 3 times 3 minus 2y equals 5. 3 times 3 is 9, minus 2y equals 5. Subtract 9. Negative 2y equals 5 minus 9 is negative 4. Divide by negative 2. Y equals positive 2. All right, now we're cooking. We got an x, we got a y, all we need is a z. So all we have to do as our next step is take x, take y, plug it into any one of these three, and solve for z somewhere. So I'm going to go with equation 1. I'm going to erase this right here. But I'm going to go with equation 1 just because it's all coefficients of 1, so we just pretty much substitute in and then solve. So x plus y minus z equals 2. 3 plus 2 is 5, minus z equals 2. Subtract 5. Negative z equals 2 minus 5 is negative 3. Divide by negative 1. And z equals positive 3. Running out of space here. Alright, we have our x, y, and z. X is 3. Y is 2. Z is also 3. So 3, 2, 3 is the solution to this 3-variable system. And just a little brief recap. There is no do this, do that systematic process. It's more of just what is a logical approach as my first step. There is no right or wrong really, as long as you're doing it correctly, but there is no right or wrong first step. as long as it just follows that process where you're eliminating a variable. So if you wanted to eliminate x first thing, you would multiply this by 2 and then subtract equations 1 and 2. Because that would be 2x and 2x, and then you subtract. And then that would give you a whole different route. So there's a whole bunch of different branches that this problem could have went down. I just picked this branch by eliminating the z's as my first step. So then that took me this way. But either way, you should get this answer any route that you take.